everyone. So we are jumping backward through chapter 9 to a small section that we kind of jumped over, and that's on graphs of polynomial functions. Just in general, what do polynomial functions look like? And the bad news is there's really not a hard and fast rule for what polynomial functions are going to look like because there's such a wide variety of polynomials. But there's a lot of this kind of thing going on with polynomial functions where you see a lot of like ups and downs. It's sort of the roller coaster type graph. And all these different numerical values, shift what's happening within that polynomial. So you are going to have to be kind of reliant on some sort of graphing technology in this section. For us this year, really we're focusing most on the use of Desmos. And Desmos does some nice things for us as far as being able to find the zeros. So for this first example, I'm not going to go over it in as much detail as I usually do with the graphing calculator because Desmos really kind of helps us out with that. But I will talk just a little bit about how you would answer a question like this, if you didn't have that at your disposal. So this graph represents this function here. And again, I would not be able to look at that function and know what the graph would look like precisely. There are some things that throughout the course of this chapter you're going to learn about, how many times it goes up and down and things like that. But these numbers don't necessarily correspond with points on the graph at all. And so it says, between which integer values do the zeros of the function fall? Hopefully you've kind of caught on to the fact that the zeros or the roots are going to be kind of a big deal when it comes to polynomials. I see two roots. I see one here, and I see one here. Okay? And notice how this, though, it comes down and then it goes back up like it's going to hit the x-axis, but it doesn't quite make it there before it turns around again. We're not talking about that so much today, but I just wanted to point that out because that's going to have some significance later on. The fact that this thing is, heading upward and then changes direction to head back down without crossing the x-axis tells you something about this function. Okay? And again, that's something that's going to come up later. So what this question really wants you to be able to do is just say, hey, this one is located somewhere between -1 and -2. So I would say between -2 and -1. And then the other one is located between -3 and -2. Oops, sorry, that should be a -2 there. So then it says make your estimation more specific. So here's what that's getting into is on a graphing calculator, if you were to graph this function, you could look at the table of values. And so you would be looking at x values, x equals -5, x equals -4, x equals -3. And your y coordinates would all be way down in the negatives. And then you would keep going, and then all of a sudden you would hop to -2, and you would have a positive y value. So here at -3, we had a negative y value. Here at -2, we had a positive y value. The fact that our values jumped from negative to positive tells me I must have crossed 0 at some point. So that's how, looking in a table, I could identify that this is between -3 and -2. And then if you look at, so at -2, I'm in positive territory, but at -1, I'm back down in negative territory again. That tells me that once again, I must have crossed over that x-axis. I must have crossed 0. So when you're looking at that table on your calculator, there are ways to make it count not just by integers, but you can make it count by 0.1s, let's say. And so then if you're looking at values like -2.1, -2.2, -2.3, you can kind of hone in on where specifically the graph crosses 0. The reason I'm not going to get into all of that right now is if you are graphing this on Desmos, you can just hover your cursor and it's going to tell you exactly where those zeros are. So you don't need to mess around with all of that repeated estimation, which is really the algorithm that your calculator uses. You can just identify where the zeros are located specifically. So calculate the zeros using your graphing calculator. We're not going to worry about being able to do that because, like I said, I'm going to be letting you use Desmos for questions like this. So just wanted to talk a little bit about that idea of crossing from negative to positive and that indicating that there's a 0 there somewhere. Okay, the more important question I think would be this example 2, and this kind of just gets into some terminology. So I've given you another polynomial function here. We don't have an equation for it, and we don't need an equation for it to answer these questions. What I want us to be aware of, and I thought this was in this example, but I guess not, some terminology that you need to know. You can have a graph have a what's called a global maximum or just a maximum. You can also have what's called a local maximum, and that's the same thing with minimum. You can have a true minimum or a global minimum, or you can have a local minimum. So, for example, if this graph keeps going forever and ever and ever, okay, in the down direction, we would say that there is no true minimum value. And again, sometimes you're going to hear that referred to as like a global minimum or an extreme minimum. Okay. However, you do have this spot where the graph is going up and then it's coming back down, and it kind of takes a dip before it heads back up again. So this is kind of a low point. This would be what's called a local minimum on this graph. So it's not the lowest point on the graph, but it is a low point. Similarly, this point here is not the highest point on the graph, but it is the top of a bump, right? And so this point would be what's called a local maximum, because it is a high point relative to the other points around it. It's not the highest point. Now, this point here is the highest point on the graph. There's nowhere that's going to be higher than that one. So this one we would just refer to as a maximum or a global maximum, okay? All of those bumps, all of those places where you see the graph changing direction, those are going to be important to you long term. When you get into calculus, those points are going to be real important for you. So just wanted to make sure we had some terminology to go along with those. Those points also are going to be important when we're talking about our intervals here. So I want to talk about, and when I say intervals, I'm talking about x values. Okay, so let's just make a note here that when I'm talking intervals, we're labeling this in terms of the x values, like between what number and what number. And that's why you see all these coordinates posted. That's what's going to help you with that. So on what intervals is the graph increasing? Let's make sure we understand the difference between increasing and positive. Increasing means getting larger. So as I'm moving across the graph from left to right, the y values are getting bigger. It's heading upward. Okay? That can happen on the lower half of the graph or the upper half of the graph. But as long as your graph is moving in an upward direction, we would say that that's increasing. Positive just means that it's above the x-axis. So if this is my x-axis here, anytime it's up here, we would say it's positive, and anytime it's down here, we say it's negative. You can be positive and be increasing, or you could be positive and be decreasing, which is what you see here. You can be negative, which is all this down here, and be increasing, or you can be negative and be decreasing. Okay? So all of those things are possibilities here. So increasing is anywhere where the graph is getting larger. So really all of this, if I'm reading from the left, everywhere, and even if this graph goes way down here, all of this is increasing, getting larger, up and up and up and up until it hits that local maximum. So I would say anytime x is less than this negative 1.064, so anything to the left of this negative 1.064, all of this on the graph is increasing because the graph is getting larger. Then we hit this little chunk here where it's decreasing, it's getting smaller. And then starting from this local minimum, you'll notice it's increasing again. So it increases from 0 to this 1.165. So it increases, it crosses the x-axis, it hits a 0. But it continues increasing all the way until it gets to this maximum. So another interval would be from 0 to 1.165. And then from there on out, all of this would be decreasing. All of this is heading downward. Okay? So let's go ahead and do, I'm going to jump out of order here, but let's go ahead and do decreasing since we just talked about that. So we said this little interval here was decreasing, right? It's going from a local max down to a local min. So if you're going from a high point to a low point, that's decreasing. So I would say that's between this negative 1.064 and the 0 here. And then we're increasing, 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 and then all of this again would be decreasing. And that goes on forever. So I would say that's everywhere to the right of the 1.165, everywhere this way. So I'm going to say x is larger than 1.165. Okay, so now let's talk positive and negative. And really, I told you already that positive is anytime you're above the x-axis, so that would really be this whole chunk of the graph here is all in positive territory. So I'm going to label that, and notice the dividing line for that is the zeros. It's no longer the max and min, but it's the roots. So 0.764 to 1.463, that's where my graph is positive. And that's it. That's the only place this graph is positive. Okay. Everywhere else is negative. So I would say everywhere less than that 0.764, so everywhere to the left of 0.764. And everywhere to the right of the 1.463. So the answers to those all look a little confusing, but that's really all it's doing is kind of talking about ranges of the graph based on these x values. And notice I didn't use the y values for this at all. It's all just about partitioning the graph using your x values here. That's really the main thing that you need to take away in this lesson is this vocabulary, the vocabulary about the max and min, and understanding that a root is going to happen anytime your y values cross from negative to positive or vice versa. Okay? That's it from me today. Go ahead and take a look at homework for tonight, and we will take questions when I see you in class next time.